This is the lesson, and you need to take notes on these. So this is all the note stuff. This is 10% of your grade is just writing these notes. But we are going to be talking about with GCO3, it's transformations of polygons. So first we're going to talk about the main transformations we have. We have, and then I don't know if you remember me doing this last year, if you had me at all, but we go like this. So these are the main translations. We do rotation, translation, reflection, dilation, contraction. So the transformations that we're going to be talking about mostly are those first ones. So we have a rotation, and that is usually about, they say about, that means like anchored on about a certain point. And so they might do things like 90-degree rotation. That's the angle of rotation. Then we have translation. And that's where you just move everything. Move it left. I'm just going to do L, left, right. And if you move it left or right, that's the X. Or up or down, and that's the Y. Rotation, translation. Then we have reflections. I'm trying to make these kind of slow, like short. Notice how I don't have a complete sentence here. I'm trying to make them short so that everybody can write them. So reflection would be across a line. It's like you fold it, and then it's a mirror image on both sides. So across a line. And that line is called, very fancily, line of reflection. Okay, so let's just go over some general things for each of these. You learned about these, because, and I know you did because I just taught it for the 8th graders. You learned about these last year. So how many degrees is it to go all the way around? Like turn all the way around? 360, right? If you go halfway, that's how many degrees? 180. If you, yeah, and then you have the 90.
45.
Okay, so you know about turns. If I had, and then you have to know, for rotation, you'll have to know rotational symmetry. That's basically if you can take a shape and rotate it less than 360 degrees and have it be in the exact same position. So here is an example of that. I have this rectangle here, and if I were to rotate it around its center like that, is that the exact same rectangle?
Yes.
Yeah, and it's in the same position, right? So that, how many degrees was that to go all the way around like that? 180. And is that rotationally symmetric if I go from here to here? No, because it's in a different position, right? On the other hand, huh?
It's the 5th, right?
It's what?
The 5th.
Today is the 5th, yes. Okay. I thought you were talking about the shape and I was very confused. Okay, then if we have things like this, does this have rotational symmetry?
No.
Yes, because in fact, how many times can I turn it where it equals the same thing?
4.
4 times, right? So I could do, for the rotational symmetry, I could do 360 divided by 4, and what would I get? How many times could I rotate? How many degrees do I rotate it, and it'd be the same thing? 360 divided by 4. 90. It could be 90 degrees. If I rotated it just 90 degrees, it would be in the exact same thing, right? Okay. What about with this one? What about with the numbers in the middle?
180.
Is it? What about the numbers in the middle? Is it the exact same thing?
No.
No, it's not. So this technically, because of the numbers in the middle, would not have rotational symmetry. How about, okay, like this one?
Yes, that one could. 180.
180, right?
Yeah, there you go.
And then Las Vegas, Nevada. This one could not, right? Because it has the Las Vegas stuff on it. Could this one?
Yeah.
Oh, could have 4, right? Okay. So those are just some examples of rotational symmetry. What if I had like a perfect hexagon? How would I find out how many You guys remember how many sides a hexagon has?
6.
6. So how many degrees would I have to turn it? 60, because I would do 360 divided by 6, and so that would be 60 degrees. Yeah. In a bit. Thank you for being quiet. And then, so we have that. And you would just have to take the things and split it up. And then I think that is, and then reflecting, you have to be able to tell what it was reflected about, is what they call it. And so if you had a picture like this, so let's see, let's take a picture. What picture do we have? Let's take the letter T. And if I were to take this letter T, does this have reflectional symmetry? Can I reflect it and be the same thing? Where would that line be? Where would the line be to reflect it across? Like right smack dab in the middle, right? Because if I folded that in half, it should be about the same thing. And then, okay, I think that's actually it. All right, that's the end of this lesson.